On the surface, the crypto markets of early 2026 are quiet, but beneath that flat price action, core infrastructure is compounding at a breakneck pace. Throughout 2025, networks focused on performance tests and developer tooling. In 2026, that focus has shifted toward whether these systems can actually survive the weight of global financial traffic. The central debate has evolved. It is no longer just a question of can it scale, but a choice between completely divergent architectural philosophies. Three major contenders are executing massive, complex hard forks this year to solidify these choices: Ethereum, Solana, and Polygon. For developers and institutional allocators, this is a point of no return. Committing capital or code to one of these chains today means locking your project into a specific set of permanent limitations. To understand which architecture is actually viable, we have to look past the token price hype and examine the code shipping to mainnet. Ethereum's 2026 strategy is a bet on modular security over base layer execution speed. The Ethereum Foundation has reorganized its development around three specific tracks: scale, improve UX, and harden the Layer 1. The Glamsterdam upgrade introduces Enshrined Proposer Builder Separation, or EPBS. It separates the actors who select transactions from those who construct the final blocks. By splitting these duties, Ethereum handles more complex block construction without forcing developers to rewrite existing applications. Following that is the Hegota upgrade, which focuses on Verkle trees and statelessness. Verkle trees are a cryptographic data structure that allows nodes to verify blocks without needing to store the entire history of the blockchain, significantly reducing the storage needed to run a node. The trade-off for this sustainability is complexity. Ethereum is baking a dense layer of new logic directly into its base layer. This choice means the base chain remains slow by design, relying on Layer 2 networks for consumer transaction speed. Ethereum is prioritizing decades-long network resilience and institutional trust over the quest for high transaction per second metrics. While Ethereum builds a modular stack, Solana is pursuing a fully integrated single-state machine. The network's Alpenglow upgrade, arriving in the middle of the year, is a complete ground-up rewrite of its consensus and block propagation layers. As this timeline demonstrates, Alpenglow replaces the network's original cryptographic clock with two new mechanisms called voter and rotor. This rewrite achieves sub-200 millisecond finality. A transaction is functionally irreversible almost the instant a user hits send. Later in the year, the SIMD 0266 standard will deploy. This upgrade targets the efficiency of token programs, aiming to reduce their computational resource usage by up to 98%. This raw speed creates a specific problem. It severely compresses the time window available for complex, privacy-preserving computations. To handle confidential transactions, applications on Solana must rely on specialized, lightweight third-party cryptographic networks to manage the encryption. Solana is trading architectural flexibility and hardware leniency to achieve the level of execution speed required for high-frequency finance. Polygon is evolving from a simple Ethereum scaling tool into a settlement layer for an entire ecosystem of interconnected networks. At the center of its 2026 roadmap is the AggLayer, a system designed to treat every connected network as part of a single, shared environment. The AggLayer utilizes zero-knowledge proofs to connect disparate chains. By proving a statement true without revealing underlying data, chains share liquidity without vulnerable bridges, letting users move assets with the lack of friction you'd expect when sending an email. The trade-off shifts the burden of trust. Users must now rely on a highly complex aggregation layer to manage assets. While this removes the risk of individual brittle bridges, it concentrates that risk directly onto the AggLayer itself. Polygon is betting that the convenience of unified liquidity will vastly outweigh the risks of centralized aggregation dependencies. In the 2026 landscape, there is no objectively best chain. There is only the architecture whose permanent compromises best align with your operational needs. Ethereum's modular roadmap is built for institutional treasury operations and tokenized real-world assets. Its economic security makes it the choice for high-value settlement, where base layer latency is an acceptable price for absolute certainty. Solana's Alpenglow upgrade is built for high-frequency DeFi, real-time gaming, and AI agent micropayments. The intense hardware requirements are a necessary trade-off for applications that require sub-second finality to function. Polygon's AggLayer is built for cross-chain consumer apps and global payment rails. This decision tree shows how Polygon's unified liquidity serves applications requiring seamless, invisible background operations across multiple ecosystems. The 2026 upgrades bake these architectural compromises directly into the code. Success depends on evaluating these constraints now and choosing the trade-off that fits your use case.